Hello and welcome. Today, we'll be talking about the molar mass and how to calculate the molar mass of compounds. Just as a quick side note, this video will not cover what moles are. That's in a different video of mine. So first off, what is molar mass? First, think of the boxes you see on the periodic table. In the middle is the atomic symbol, which is the big letter that first catches your eye. Right below it might be the name of the elements. In this case, it would be hydrogen. In one of the corners, hopefully, is the atomic number, which represents the amount of protons in the element. And finally, at the bottom is the molar mass, which is a very specific number and our topic for today. Basically, molar mass is just how many grams a mole of something, either an element or a compound, would weigh. So back to hydrogen. The molar mass of hydrogen is 1.008, which means that there should be 1.008 grams of hydrogen in a mole. But that's a specific number, an oddly specific number. Like, why the 0.008? It just seems excessive, right? Well, the 1.008 is just an average of everything, and it's because of isotopes. Isotopes are different amounts of neutrons in an element that results in a different atomic mass. So for example, hydrogen has 3 isotopes. Usually they're marked by their atomic symbol, followed by a dash, and then the atomic mass, which is just the number of protons and the number of neutrons added together. But in hydrogen's case, the number of hydrogen 1s, which means there's just the 1 proton, is a substantial amount more than everything else, which means that the average of the numbers will be closer to 1 rather than anything else. Alright, cool, but how do we calculate them into compounds? Well, it's simpler than you think. You just add. So take water, for example. It has 2 hydrogen molecules and 1 oxygen molecule. In this case, you just add the molar mass of the 2 hydrogens with the oxygen, and you get roughly 18.015 grams per mole for the molar mass of water. And this applies to every single compound, even the most complicated compounds. Take ATP, for example. It's a very long and complicated compound often found in living matter. In this case, if we very painfully add up all of the molar masses, we get a total of 507.18. And in this case, it's also grams per mole. And that's it. In this video, we covered molar masses, isotopes, and how to calculate the masses of compounds. Thank you for watching!